Right, hi there. We are going to look at a skill today that's linked to the National 5 Maths course. Now, before we do that, what I would suggest that you do is have a wee go at these starter questions. So in a second, pause the video because I will be going over the answers, okay? So have a go at these just now. Right, hopefully you've had a chance to do those questions. Now let's have a look at the solutions. So the first question, what we're looking to do is we're looking to simplify the fractions that we're given. So for instance, if I quickly get the pen that I'm looking for, we have got 18 over 99. Now what we're looking for is we're looking for the largest number that goes into both the top number and the bottom number of the fraction, okay? In this occasion here, the largest number that goes into both top and bottom is 9. So essentially what I'm going to do is I'm going to divide the top number by 9 and I'm also going to divide the bottom number by 9. So that there would be 2 and that number at the bottom would be 11. So that's exactly the same as 2 11ths. Question number 2, we've got 60 over 360. Now, it's not absolutely essential that you find the largest number right at the beginning. You might, for instance, realise that 60 over 360, well, both of those numbers are clearly divisible by 10. So if I divide the top number by 10 and the bottom number by 10, you will see we get 6 over 36. And quite often, you might be able to simplify it a wee bit further. Now, I can see clearly that I could actually divide the top number by 6 and the bottom number by 6. So this becomes 1 over 6. So 60 over 360 is exactly the same as 1/6. And moving on to the last question, we have got 18 over 360. Now, different ways of doing it. You can break it down. You could see that both numbers are even, for instance. You could divide both top and bottom by 2. You'll see you get another fraction and keep breaking it down. Alternatively, you may have spotted the largest number that goes into both top and bottom, okay? Their highest common factor, if you like. And that number, on this occasion, was 18. And I can divide both the top and the bottom by 18. And 18 divided by 18 is 1. And 36 divided by 18 is 2, so 360 divided by 18 must be 20. So 18 over 360 is the same as a 20th, okay? Moving on. Now remember these questions that we always do, we always do it as non-calculator, so hopefully that's what you did because that's what I'm going to be doing. So if I have a wee look at the first one, whoops, a daisy, too far. And then my pen, okay. We know that to find the area of a circle, we do A equals pi r squared, okay? So in this occasion here, pi, we are going to use 3.14 as pi. I'm going to times it by the radius squared. So we've got 20 squared there. So just to remind you that if we've got 20 squared is the same as doing 20 times 20, okay? Now I could break that down all day if I like. I could imagine that 20, well, that's the same as 2 times 10, isn't it? So I could think about it as 2 times 10 times 2 times 10. Then what I'm going to do is I'm going to just rearrange these numbers, okay, because I don't have them in any order. And I know that 2 times 2, well, that's just 4, isn't it? 10 times 10, well, that's 100. So I've got 4 times 100, which is 400, okay? Seems quite a lot of working to get there, but it's nice and simple. You may have realised right at the beginning, I know that 20 times 20 is 400, and you may have just changed it straight away, okay? That's another wee strategy in case you like it. Moving on. That means my question was 3.14, and I'm going to multiply it by 400. Now, same sort of principles, actually. 3.14 times 400, well, I know that 400 is the same as 4 times 100. Now, I like to split it up that way because what I'm just going to do to the side is I'm actually going to do 3.14 and I'm going to just times it by 4. So 3.14, going to multiply that by 4. 4 times 4 is 16. 4 times 1 is 4, plus the 1 is 5. That decimal point always makes a nice straight line. And we've got 3 times 4, well, that's just 12, isn't it? So what I get for that bit that I underlined, that is 12.56. And I need to times that by 100. And to times that by 100, that decimal point, you know, you can imagine it moving 2 places to the right, or imagine your numbers moving past the decimal point and going to the left, whatever way you want to think about it. But at the end of the day, you know the number's going to get larger here, don't you? And I'm not going to forget my units at the end. So 1,256 centimetres squared. That would be the area of a circle with a radius of 20 centimetres and a diameter of 40 centimetres, okay? Right, moving on to what today's lessons look at. So today's lesson is looking at finding the area of a sector. So we are learning how to calculate the area of a sector. So the first thing we need to know is, what is a sector? So, a sector of a circle is like a pizza slice, okay? It consists of a region bounded by two radii and an arc lying between the radii. Now, that sounds quite complex, but just let's break that down a wee second and what that actually means. So, for instance, if I get my wee pen, here's the radius of a circle. So, radius is singular, radii is plural. So, we've got that radius there. We've got another radius here. And what we have is we have got the arc. And I'm trying my best doing it freehand, worst effort ever. But that there is essentially our sector, and I'll just shade it in. I'm talking about this bit here. This is our sector, okay? Now, the key thing is that you realise one bit here, okay? And the bit I want you to realise is it is just a fraction of the area of a full circle. So if we know how to find the area of a circle, and we know that this is just a fraction of the circle, then hopefully everything should be fine. So let's have a wee look at a question putting that into practice, okay? So we'll move on to this slide, okay? Well, actually, I'm telling a wee fib. Before we put that into practice, let's have a look at the two different types of sectors that we need to know, okay? So let's go here. Now, I'm going to think about the angle size of the sector. So I'm thinking about this part here. Now, this part here, hopefully you would agree that that angle there is greater than 180 degrees, okay? I'm going to do the same for the blue one. This angle here is less than 180 degrees, okay? Now, that's going to dictate what type of sector that we are actually calculating. Now, if your angle is larger than 180 degrees, then this here is going to be known as a major sector. So we may have to find the area of a major sector. And you could probably guess the next one. The next one here, if your angle is less than 180 degrees, then it's known as a minor sector, okay? Now, obviously, if it's bang on 180 degrees, so if it was equal to 180 degrees, then that would be recognised as a half circle, okay? So we are talking about something that's less than or something that's greater than, okay? So let's put this into practice. So here we have a minor sector, okay, because I can see that the angle is less than 180 degrees, and we want to calculate the area of it, okay? So let's have a wee look at how we do that. So the area of sector is equal to. Now let's build upon what we already know. Now we already know how to find the area of that full circle, okay? If I was asked to find the area of that full circle, then I know I would do the pi and I would times it by the radius squared, okay? Now we are not asked to find the area of the full circle. We are only interested in a fraction of the circle, okay? Now the fraction that we are interested in, let me get rid of some bits, is that 60 degrees, okay? We're only interested in that 60 degrees. So we are only interested in that angle at the top there, right? Now we know if it's a full circle, it will be out of 360 degrees, okay? So that fraction at the front is absolutely essential. So what we're interested in? Well, we're interested in 60 out of the 360. So I'm doing my substitution in. My radius, I can see from the middle to the side is exactly 12, and it's 12 squared. Now, what you will notice here is this fraction at the front. Now, that I'm going to do this in my calculator, but let's pretend this was a non-calculator question. What's always good practice is if that fraction at the front is, you simplify it, okay? You want to make the numbers as user-friendly as possible. Now, we know from earlier that that fraction there is exactly the same as a 6. So what I'm going to do is I'm going to write that equivalent fraction. I'm just keeping everything else exactly the same, and that'll make my life a wee bit easier, okay? Now, I'm just going to talk you through how you should put this into your calculator. So I'm just going to use green here. The first thing I would like you to do is I want you to use pi, and use the pi button, okay, times 12 squared, okay? So we're going to do pi times 12 squared. Once we get that answer, we're going to divide it by our denominator of the fraction, so we're going to find 1/6. And often what we would then do is we would multiply by this top number, okay? But in this occasion here, we've got the number 1, and then we know if we times something by 1, we're going to get exactly the same answer. So that means that if you've put in correctly, you will get the answer 75.40 centimetres squared, okay? And that's my final answer. And make sure you don't forget your units. So area we know is centimetres squared. So that's a nice basic question. If I was asked to find a major sector, then the only difference is that angle at the top, rather than be 60, it's going to be greater than 180 degrees, okay? But it's exactly the same skill. So let's have a wee look at a different style of question, okay? Applying these skills. So if you look at this one, right? So second example, calculate the area of the shaded section, okay? Now, our shaded section here, you will see, it's not actually a sector. It's not a sector, but it is the difference between two sectors. So for instance, if I just highlight a couple of bits here for you, I'll use pink colour here. Now this here, I'm going to refer to this as our large sector. You can see that one there, okay? Now obviously that is not what we're asked to find, okay? But I also have another sector here, okay? And I'm going to use, let's go for green this time. I have this smaller sector, don't I see this one here? And if I can work out the difference between the large sector and the smaller sector, and when I use that word difference, remember what that means. In order to work out the difference between two numbers, we subtract. And if I was to subtract that smaller one, then that will leave me with the area that I'm looking for, okay? So it is the difference between the two sectors. Let me get rid of that just now. So I'm going to do my working for this. I'll go to my pen. So the first bit that I'm going to do is, I'll look at the small. Let me find the small sector. So I'm going to write word small, right? I'm going to abbreviate. Area of sector is equal to the angle out of 360 times pi r squared, okay? So the angle you can see is 40 out of 360 times pi times the radius squared, okay? Which is 12 squared for the smaller sector. Hopefully you would agree with that, okay? Now, I'm going to do pi times 12 squared. I'm going to divide that by 360 and I'm going to times it by 40, okay? Because I'm going to assume that this is a calculator question, so I can go straight for that. And what I get as an answer is 50.27 centimetres squared, okay? Then I'm going to do exactly the same thing, except for this time I'm going to find my large sector. So to find it is the area of the sector is equal to the angle out of 360 times pi r squared, okay? And the only difference is the angle's the same, but the radius of that sector is slightly different, isn't it? It's not 12 this time, it is 19. So I'm going to times it by 19 squared. And what I'll do is I'll put that in my calculator. So I'm doing pi times 19. So sorry, pi times 19 squared. Getting that answer, times it by 360. Actually, sorry about that. It's pi times 19 squared, divide by 360, and then multiply by 40, okay? And once we do that, we get 126.01 centimetres squared. And I can then go ahead and answer what I'm asked to find, which is the area of the shaded section. So to get the shaded area, and I apologise about my writing, it's quite tricky in the tablet. It's not the best at most of the times, but we'll get there. The difference, I'm subtracting those. Now remember, even if you made a mistake beforehand and you're showing that line of working, we're still going to get some answers here, or marks I should say. So 75.74 centimetres squared would be your final answer for that one, okay? So I guess that's a wee problem solving question to have a wee think about, okay? Now, just to formalise things and what we've done in those previous questions, now, I don't really want you thinking too much about a formula here, because you should understand it. We know how to find the area of a full circle, and we understand that a sector is just a fraction of the circle. But if you did want to formalise it a wee bit more, you can think about it as area of sector is equal to the angle of the sector, divide by 360, so that'll be the fraction, and we know that a full circle is pi r squared, okay? So hopefully you've got a greater understanding of where that actually comes from. Right, so our success criteria, or steps to success as I prefer to call it. You know how to find the area of a full circle, which is absolutely essential to this. And what we're just embedding here is a fraction really. But that sector is just a fraction of a full circle. We can apply a valid strategy to calculate the area of a sector, so that's what we've been doing. And we've looked at some problem solving, and we've discussed about how it's important to both calculator and non-calculator problems. So hopefully you're quite confident with that. Like anything, it's important that you get a wee bit of practice to actually convince yourself what stage you're actually at, and that's what you're going to be doing next, okay? So there will be a task assigned to this. The task will be put on Teams. Once again, if you have any problems at all with the task that you've been assigned, you know you can post it on the Teams page, and I will get back to you. There will also be times during the day that I'll be on live for you to come on and ask questions verbally as well, which is sometimes a wee bit better because it means I can scribble down and show you some solutions as well, okay? Right, thank you very much. I hope that was of help to you.